Hello and welcome to everyone. This is Neeraj Gautam. In our previous class, we discussed about the numericals based on the inertia force calculations in reciprocating engines, and we also defined the turning moment diagram. We saw the turning moment diagram for steam engine, for IC engine, four-stroke IC engine, and for multi-cylinder steam engine. Now, from this lecture, we are going to start the flywheel. So let's start the flywheel with the definitions. A flywheel is a mechanical device which is used to convert the angular momentum to the stored rotational energy. A form of kinetic energy is also proportional to the product of moment of inertia as well as square of the rotational speed. We know that the kinetic energy of the rotation is given by this relation 1 by 2 I omega square. So I is the mass moment of inertia and omega is the angular speed or rotational speed in radian per second. So the flywheel is a device whenever the energy is available in excess, it stores in it and supplies again to the device whenever the device needed some amount of energy for its proper working. So the common uses of flywheel includes smoothing of power output of a energy source. For example, flywheel are used in reciprocating engines because the active torque from the individual pistons is intermittent. We know that in engines there is a fluctuation of energy. That means during power strokes we are getting more amount of energy, and during other strokes we are not getting that much amount of energy. So in other strokes we need some energy to run the system because of the resisting torque or the frictional resistance involved in the engine. To run the engine we need some energy. These in these low energy strokes or low energy portions, these energy are supplied by the flywheel. So flywheel smoothen or reduce the fluctuations of energy in the engine during a cycle. Flywheel is used to store the energy. Definitely it is storing the energy when they are available in excess and supplying again to the system when the system needed the energy, delivering the energy at the rates beyond the ability of an energy source. Many times it happens that we need a more amount of energy required, and this energy is stored in the flywheel. Flywheel continuously stored energy in it, and whenever we need it, we suddenly move the energy from flywheel to the system. So if the energy source has not a sufficient amount of energy, then we can give a simple thought that the energy is continuously supplied to the flywheel. Flywheel will store it. When an abundant amount of energy is stored in the flywheel, then we suddenly release this energy to the system at which we want to perform the desired work. So suddenly system get a certain amount of energy which required by it, and which cannot be possible to supply directly from the source. Flywheel is used to the controlling the orientation of the mechanical systems like gyroscopes and reaction wheels. Now, the same device we studied earlier, that is governor. Governor is also used to maintain the speed fluctuations, but the flywheels maintains the speed fluctuations during a cycle, but the governor maintaining the speed fluctuations because of the load, increase or decrease in the load. So let's see the difference between the governor and flywheel. Here the flywheel, the function to control the speed variation caused by the fluctuation of the engine turning movement during a cycle. So there is a variation in the turning moment value during a cycle. We earlier discussed this. The turning moment value continuously changes as the crank angle increases from 0 to 180 and 180 to 360. And governor has a regulate the mean speed of engine within the prescribed limit when there is a variation load of load. It works for the variation of load. It works for the variation of the terminating moment available during this cycle. Okay. Mathematically, flywheel controls the rate of change of speed and governor controls the change in the speed. The flywheel acts as a reservoir to store the energy due to the mass movement of inertia and release this energy whenever required, where governor is regulating the speed of the engine by controlling the quantity of working fluid or fuel supply. Flywheel regulates the speed in one cycle only, and governors regulates the speed during a period of time whenever there is a load fluctuation available. The governor is used, but flywheel has to maintain the speed during each cycle. Flywheel has no control over the supply of fuel or charge. Governor takes place the changes the quantity of fuel to maintain the speed. It is not essential element for every prime mover. It is used when there are undesirable cycle fluctuations. And governor is essential for all devices because the power fluctuation occurs because of the load. Okay, so it is the essential component of the prime movers. It is not the essential component of prime movers. Okay,